In my last demonstration with the transformer, I showed you how it's alternating current on this transformer plugged right into the wall out of a microwave transformer, or a microwave, this microwave transformer. You get an alternating current all the way down, and we did the range, you know, levitate and eject. And, you know, whether that magnetic field is rotating down the pipe or up the pipe, I'm not sure, because it pulls steel down and it pushes the eddy currents, push the aluminum up. So maybe it's just this can't follow suit, so it pushes it away. Over here I've got a steel bolt with a decent sized wire wrapped around it about 20 times. I tried to use a battery and make it a DC current, you know, and I wind up with just the north pole, but I don't have a big enough battery or big enough wire on this bolt. It'll jingle just like that, but it won't hold it up. It just moves it. Just moves it like that. It will not levitate, and it won't shoot it off there. It just kind of does this with this little one, and the bigger ones just barely move. So I tried DC. I don't have enough power. I need to link several batteries together to do it. I will try that someday. But we did this in my last experiment. Now I want to show you what regular magnets do in this tubing when you apply them, just pulling them in and out and rotating them. And we'll do that. I had a viewer ask some questions about my last video about electromagnetic and magnetic differences between them. And other people said other things, and haha, whatever. Try it yourself and let me know. I replied back to him that it didn't work well, but that was with it this way, with the magnetic field south and north vertical inside the tube. It grabs a little. If you pull it up, if you see that, it doesn't do it much on the quarter, but it does grab with this one. And to a certain extent, you know, it does pick it up with it this way. And even this tall one, it shakes it, but it don't have enough grab to pull it. So then what I tried, and I told him that didn't do a whole lot, so I put the magnetic field the other way. If you notice, like I said, this one is this way. The poles are up and down vertical with the hold of the tube. That you just saw what that does. So now I've got it the other way. The magnetic field is crossways. And if I stick it and lift it, I don't get anything. But if I spin it, I get just a little bit of movement. And this one, if I just lift it, I get a little movement. Let me show you. Little movement, about the same that this one did. But this one actually grabs it more. If you see that. I'm just using my hand to pull that out. Let me do this. Show you the difference between the two orientations of the magnets. That lifts it pretty good. That not so much. Okay? So with the magnetic field south and north this way, it doesn't really grab. You think it would, but it doesn't. With it this way, it does. It does grab it. And that's about 1.5 inch tube. And we'll do the same thing with the 2-inch tube, but in that way, and it moves it pretty good. And the faster I pull it out, the more it moves it. This one doesn't do quite as much. Almost. And in this one, the 3.5, it lifts it. And the 3.5 with it this way, it lifts it. And like I said, the speed does matter. Didn't realize that before. I don't know if I can go any faster. Well, it slid against the side that time. So it does pull it up, this one. Now I'll try the other one on the 4-inch. And try the round one this way on the, it's about a 9-inch tube. I can feel it drag, but I don't get a lot of lift. With that one, Get a little more drag with this one, but not enough to lift the tall one. The tall one's just too heavy. So what I also wanted to show you was, if I spin it, this one with it crossways, not much at all to quarter. And it does about the same with the others. It'll lift them up just a little bit, but it spins them. So they always fall, almost always. And do the same. None off of that one. Do the same with this one. Nothing there. A little bit. I get that without spinning. It grabs. That one grabs without spinning, and when I spin it, not as much. So if I go up with this one without spinning, it grabs pretty good. But if I spin it, it seems to grab a little less. So it's kind of got me baffled. Straight up, do it again, straight up, and then I'll spin it. And that one's almost the same. But anyway, so that's it. Magnetic fields have a little difference in orientation to the tube, but they both do grab and they do spin them somewhat. So, you know, it's wild how this one grabs so much, even though the poles are north and south, or up and down in the tubing, and this one seems to do about the same. So it's real close. They're real close, even though it's completely 90-degree orthogonal orientations of the poles. They're real close to the same. Wanted to show you that. Okay, got two magnets here on steel bars. This one is magnetized this way. If you see the line, north and south, south, north, like that. It's magnetized through this way. So it's magnetized crossways with the bolt, okay? This one is magnetized with the bolt, north and south, if you see that. I guess you believe me that the north and south, the red and blue are north and south. But anyway, we'll start with the other one. And I'm gonna put this is just a steel ball. It's not magnetic. There's two of them. They're not magnets, not magnetic. So I'll put the ball outside this piece of aluminum pipe. And you saw what we did with the pipe, how it, you know, it moves when you move the magnet. If I put a steel ball out there, if I try and rotate the bolt, the magnet wants to move and rotate, but the ball keeps it from really moving. And I put the tape on these so you can see which way I'm turning them. So hopefully you can see this. If I turn it this way, which looking down will be clockwise, I can't hardly turn the magnet because it's dragging the ball around the aluminum. It just drags it with it. And I can show you this way. Well, let me do it this way, I guess. It just drags it. It drags that steel ball with it. And I can make it flip, but it's real hard, see? Real hard to make the magnet flip to the other pole. Almost impossible, because the magnet, or the steel ball, wants to drag rather than let the magnet flip. So that's how strong it works in that orientation. And the same thing kind of happens here on this. It's just a piece of aluminum plate, not as thick as this tubing, but it's just a plate. Which this stuff's kind of cool, what I found out. And I'll show you more in a minute. But anyway, if I put that on there like that, if you watch the tape, I'm going to rotate it that way, counterclockwise, and it goes this way, right? You see that? If I rotate it this way, everything rolls that way. Okay? Because the magnet is rolling along the aluminum the direction that I'm making it roll. But this will flip poles in this orientation. If you see that, it's like a gear. But it pulls it with it as it goes. I guess you can see it. Let me try it this way. Like I said, the tape's just to show you which way I'm turning. I rolled it the wrong way. But anyway, it's like it's opposite. When I rotate towards me this way, the magnet goes that way and the ball goes that way. Which makes sense. The magnet's rolling with the direction I'm rolling it. But with the poles, this way it jerks to the pole. So it's like that. Now what's cool is the orientating the magnetic field the other way. And it works the same gear ways, but it works so smooth. Watch the tape, the direction the tape goes, and watch the direction that the ball goes. They're opposite. And the magnet's rolling around, and I'll show you. It's rolling around inside the tube the same direction that the steel ball is moving. And I don't want to go all the way around in this orientation because of the weight of the ball, but if you watch, it's like a gear. Let me try this small one. It kind of works better in this orientation. I don't know if you can really see it. Let me try turning this way so you can see the tape better. Maybe if my hand doesn't get in the way. See if you can see that. I don't know. It won't go all the way to the top. But the cool thing is how it works vertical this way. And the little one will do it. I have to get it going. It's just too little for that orientation. The big one works better. It's like a gear. It just rotates like a gear. And there's no jerking to it because it's in between the poles, so it just works that way. And let me show you this on the flat piece too, on the plate. And you'll be able to see it. It's kind of reverse. The ball just follows the magnet. Like so. And you can see the tape, I guess. You know, back and forth. It's going opposite direction. Same thing it did the tube. Anyway, it's like a gear. They work like gears together. Especially with the orientation this way, using the side of the magnet right there between the poles. It works real smooth because both of them are trying to balance it between, but it'll follow it like that. It follows it just like that. But it looks like the ball is moving in the opposite direction of rotation that the tape is, because it's like a gear. It's making this spin the opposite way in rotation direction, but it's actually just like a gear. Anyway, I thought that was cool. Laters.